Yeah, good morning, everyone. I'm Prasanna PM, and it is an absolute pleasure to welcome you all to this webinar on integrating BIM and GIS. Today, we will explore how two groundbreaking technologies like BIM, that is Building Information Modeling, and GIS, that is Geographic Information Systems, can converge to refine how we approach design, planning, and management in various sectors. Okay, anyone know what is BIM actually? Am I audible?
You are audible.
Yeah. Can anyone please tell what is BIM? Yeah, the building information modeling is what is the abbreviation for that? What is the meaning of building information modeling? I'm asking actually. BIM is not just a software actually. Building information modeling is not just a software, it is a process for creating and managing digital representation of physical structures, whichever we have. It enables us to design virtual models of the building that incorporate every detail from materials to utilities actually. And can anyone tell what is GIS? Okay, GIS is Geographic Information Systems. That is a technology centered around spatial data. While BIM deals with structures, GIS provides the spatial context, that is the environment in which these structures exist. Let's see some of the key features of BIM and GIS.
सर सेशन को रिकॉर्ड कर सकते हैं क्या?
Yeah, it's being recorded actually.
ओके सर.
Some of the key features of BIM is like detailed. BIM is actually a detailed building-centric data, which means BIM focuses on the miniature of the structure, ensuring every component is accounted from walls to the HVAC systems, and its life cycle management can also be done for the buildings. From design, construction, operation, and even the demolition part can also be managed in this BIM. And the 3D visualization can also be done, which are crucial for conceptual and conceptualized complex projects. Then we'll move on to the key features of GIS. GIS will store the geospatial contexts of the buildings, and the border area analysis also will be stored. And we can visualize the layers, different types of layers. And the decision making is also supported in the urban planning and all. Now let's see why is it so important to integrate BIM and GIS actually. It enhances the decision making ability. With the combined power of BIM and GIS, we can make informed decisions that consider both the buildings and its environment. That is, we can consider the building details, everything, and also the environmental conditions like the infrastructure, environmental conditions for the urban planning and infrastructure also. Integration bridges the gap between architects, engineers, and urban planners actually, and applications across the domains also will be there. Let's see about the benefits of the GIS integration. It gives a comprehensive insights. By overlaying the BIM data onto the GIS maps, we can analyze how structures interact with their environment, and we can streamline the workflows. It improves the cross-disciplinary collaboration. That is, architects, engineers, urban planners, and policymakers can work on shared data sets. And also, we can get the enhanced visualization. Like by overlaying the 3D models onto the geographic maps, we'll get the exact visualization of the terrain, roads, and nearby infrastructures also. Now let's see how we can connect Revit and ArcGIS Pro. We can actually export the Revit models in IFC format or DWG format, and also it can be exported as the RVT format also. The workflow goes like this. We can prepare the Revit model in the Revit software and export it into compatible formats that can be IFC or DWG or the RVT file itself, and import it into the ArcGIS Pro. Directly we can import the models into the ArcGIS Pro, and we can place it in the geospatial context by georeferencing the BIM models. Some of the real world applications are like urban development. We can do designing smart cities that balances sustainability, functionality, and aesthetics. In transportation also we can use this integration part by planning roads and railways while accounting for terrain and environmental impacts. And environmental management can also be done by monitoring the natural resources, protecting ecosystems, and planning green infrastructures. And in some emergency situations like disaster resilience can also be done. We can build the infrastructure that can withstand floods, earthquakes, or other disasters. Yeah. Why we use actually Revit for BIM? It is actually useful to use the Revit because the work sharing allows multiple users to collaborate on single project simultaneously, and the schedules and quantities will be automatically updates when the model changes, ensuring consistency. And also we can model the parametric components. We'll do a practical modeling in the Revit, like by creating 3D structures, walls, floors, and roofs, and some parametric designs, adaptive and family libraries. Will take some windows, doors, and everything, and will model a simple floor plan now. This will be like a demonstration for creating a model in the Revit architecture. First, we'll set up the project by opening the appropriate project template, and we can have the, we can insert the floor plan, which is created in the in CAD. That is by linking the CAD file. So we'll have it in the DWG format. We'll link it into the CAD, Revit. Now here we'll have the floor plan, which is created in AutoCAD, or which can be imported as DWG format. Here we will measure the wall dimension, and we'll create the walls, windows, doors, everything. We can create it and model it in the Revit. For example, we'll measure the wall dimension. It's 150 architecture wall. We'll have the families, wall families. These are some of the wall families which come default with the project template. We can actually duplicate it. If we don't have the wall type which we need, we can duplicate the wall. Like we need 150 thick wall, so we'll duplicate it and create our own thickness wall. That is 150 Create. Okay. Now we can create the wall. The exterior wall is 150 but the interior wall we did not measure. We'll check it once. Like how much is the interior? It's 120. We can create the 120 wall also. Now the walls, everything is created. You can visualize, see it in the 3D view also. Like this, it will be created. Like this, it will be created. And now we'll place the windows, doors appropriately wherever we want. We'll go to door command. We'll have different types of doors. You can select any one. We'll click here. One more is here. If you want a different family, like the door, this is a single flush door. If you want double door and all, we can load the family. Like we'll have the libraries, Revit libraries pre-installed. When we install the Revit software, we can go to the door family folder. Here we'll get different types of doors. Whichever we want, we can select. Like we'll select double door, double glass door, open. We can select the whole list of doors. And here for the main door, we'll click here. For puja door, it's very small. The width should be small. That's why we'll create a new one. Like we'll duplicate the same. Like let's say some 700 width, and we'll give this. Okay, width should be 700. Click apply. Okay. Now the door width is smaller. Click it here. In the 3D, we can see the doors, everything. This is the main door. These are the two doors, and this is the puja door. Here we had some openings to the kitchen and the dining hall, right? We'll give those openings here. By going to modify tab, we'll split the walls, split by gap. We'll split it. How much all and we'll delete that. Here also same thing. You can adjust these openings to the floor plan which we had done in the this one. So this is the dining area where we can place the family like components. We have the dining table also preloaded. Like we'll go to load family. In that we'll go to furnitures folder. Furnitures. There we'll go to tabs for table folders. Around we'll have with chairs also we can get. Click OK and place it here. You can also change the size of the dining table. This will be the 6-chaired dining table. If you want, what is it? Couch on the hall. In the hall, you can also place the couch also. You should load the family. Excuse me. Seating. Sofa with deck. Any sofa you can select. Okay, place it. Now if I go to place the windows, actually, we'll place the windows also. This will be different types of windows. There will be here the window was there. Here it was. In 3D view, we can see like this. Here we have not modeled the floor actually. For that we need to model the floor first. We can go to the level 1, can go to floor, floor architecture. We can draw the boundary here. This will be a floor. You can see this is our floor. We can add the materials, everything to this. Like we'll add the roof also for this. For that we need to go to level 2. Here we have to select roof by footprint. We give some overhang. Click on OK. Like this, it will be created. Like if we want the flat roof, we can change the slopes to 0. This is a simple house creation. This is like a modeling, 3D modeling of a building in Revit. Now we'll understand how we can take this model to the ArcGIS Pro and georeference the model there. Was my screen not visible?
It's visual, sir.
Yeah, but the modeling part and all you got to know, right?
Yes, yes, yes.
Thank you. Yes, tell me, Pankaj.
सर ये प्रोसेस के लिए क्या
Yeah.
हमें जैसे अभी हम क्या करते हैं कि क्रैक वर्जन यूज करते हैं, तो क्या इसके लिए पेड वर्जन हमें नीड पड़ेगी?
No, if you are practicing, I mean, if you are not using it anywhere, like for commercial purpose, you can use the other versions also. If you are using it for the commercial purpose, like you are selling it to any other clients or something, you need the licensed version only.
Okay, sir.
Now it's visible, right?
Yes, sir.
Yeah. So in this, we should open the 2D layers any one of the 2D, I mean 3D layers, not the 2D one. This map will be the 2D layer, right? We'll open the local scene here. We'll take the example of our office building, which we have created for georeferencing part. So this is our RVT file, which we can directly drag and drop into the map. The data is added. We'll zoom to the layer. See, it is added on an ocean actually because the coordinate system is not defined. So we'll georeference this in the ArcGIS Pro. Some layers would be turned off, so we can turn on the layers here, whichever we have modeled. We'll search for our location. Actually, the base map loading takes some time. It's loading actually. Let's wait for that. This part is our office location. We'll georeference the office building here. So we'll go to BIM data. We click on georeference. It says like it is in unknown coordinate system. So it to the maps coordinate system. We'll click OK. We can preset the maps coordinate system whichever we want. See here we can move the layer to the display. It will get moved here. Now we can georeference by moving this using the points. We can save this after the georeferencing is done. It will take some time to georeference the building. You can close the georeferencing part. You can see the building layer is added on the geospatial layer. You can adjust the size of the building according to the base layer actually, and you can also change the base maps.
Prasanna, you have a question in chat, check.
Yeah, just a minute. What is the various applications where this technology is used? Actually, I've explained the various applications. The real world applications are like urban development, where we can design the smart cities before the smart city is already been constructed. Actually, we can plan it, design it, and everything we can do it in the, what is this, virtual environment only. Later we can develop it on the real world, and we can also use this BIM and GIS integration for the transportation also, by planning the roads, railways accordingly, which can have the terrains and environmental conditions can also be added there. And some disasters can also be controlled by knowing the earthquake, flood, and other disaster frequencies. We can construct the building according to that uh, impacts. These are some of the applications using these two technologies we can integrate using.
Okay. Is it used for construction also?
Yeah, you can
In
use it for construction.
construction.
This is actually the BIM part is purely for construction only. If we add,
Okay.
if we integrate it into the GIS part, we'll get the various this one, like impact from the floods. Flood data can be added into ArcGIS Pro, and we can analyze with the buildings actually how
Okay.
the building can withstand. Everything can be analyzed in this.
Okay. Okay. That's fine. Thank you.
Yeah, you're getting. The height of the building will be known. That is, will while creating it in the Revit only, will decide the height of the building. Like the real world planning will be there, no? The, like, we'll know the height of the building before the construction only. Like how many floors we'll construct. We'll first plan it and design it in the ArcGIS. I mean the Revit software. What is the error you will get? I did not get this. RMS error. Shankar?
Yeah, that is root mean square error we will get no while usually georeferencing any of the imagery or vector files.
Okay. Just actually, that my friend Hansa will answer that.
You can use RMS error you'll get. So you can use move to display to get the approximate location of the particular building. And then you'll have control points, right? You'll have the coordinates for where you have the building placed, right? So you can have your control points. So then once you get the approximate location, using those control points, you can get the exact location. So that will reduce that RMS error.
Yeah, one more method is like we can use the control points also to move the building. Like if we have the control point, this one, let's say we have the control points. Sure. See here, two control points are there. If we have this control point before only, we can move the building or any other things according to those two control points. This method can also be used for georeferencing. If we don't know the location, we can zoom it to the control point, this one, zoom to layer, and we can move the building or anything there. Like move to the display, we can. Yeah, that's all about the webinar. If you have any queries or questions, you can ask.
Sir, it can be possible in ArcMap?
ArcMap, it's not possible actually. ArcGIS Pro is needed.
So, Prasanna, hello,
Yes.
am I
Yeah,
audible?
tell me. Yeah,
This is
tell me.
Shwetal. So, I
Yeah,
joined little bit late. But let me summarize what you did. You have taken a 2D file in the, sorry, 3D. You have taken a 2D drawing in the Autodesk. Then you brought
yeah.
it into the Revit. You create a 3D
Yes.
model by giving them a Z coordinate, correct? Height,
Yes.
basically.
Not a Z
Okay.
coordinate. Full whole 3D modeling is done in Revit actually.
only Revit only. But let's
Yeah.
say if I have a 2D file, I wanted
Yeah.
to convert it into 3D and then
Yes.
bring it to the GIS. Okay.
Yeah. Yeah.
GIS coordinate, let's say, may be available or may not be available. That could be a two scenario. Is there any
Yeah.
way we can automate this entire process, entire automation without manual intervention? Do you have
Actually, for
something?
the
Have you done something on that one?
it's possible actually, but before that, we need to take it into the Revit actually. For modeling, at least we need the manual support for the automation directly. If we have the direct model 3D model, we can automate it into the ArcGIS Pro or into Mapbox is also there. That we can automate, but we need the Revit file or the 3D file.
But Revit file
After
may
the
be
modeling part,
available
then
for
yeah,
some of the part of the city, but
yeah,
for some of the part
yeah,
it is studio that is available. Maybe DWG
yeah.
available.
That's what we need to model it first and export it as what is that
Prasanna,
IFC format. Yes.
yeah, that means basically we have to capture the data in AutoCAD, okay, whether it is 2D or 3D, and
Sorry.
then we take
Sorry.
first first the data,
No, no,
okay, the
you're not
basic data
audible
is
actually.
created. Hello, hello,
Hello. Yeah.
hello.
Tell me.
Yeah, actually, I was just
Yes. Yes. Tell
asking
me
you.
now.
Okay, we have to create
Yes.
the TWG data first in AutoCAD, and then later on we take the data into the Revit.
Not necessarily.
Not
Yeah.
necessary means,
It's not necessary to.
sorry,
Sorry.
hello. Yeah, I can't hear.
Yeah. Yeah. It is not necessarily you should have the AutoCAD data only. You can have the lidar data also, like the 3D scan of the building also. If you have, you can integrate it into the Revit file. That means it will be more easy for you to model the components of the building, not only the AutoCAD file. I have shown you just one example,
Okay,
like
okay,
how we
okay.
can
So
use the
you can
Revit. Yes.
take the data from various platforms, like various format
Yeah, yeah.
data we can take, right?
Yes, you can
And
take.
for modeling,
Yes,
we are
the
using
lidar
Revit.
scan data.
Yeah. And for modeling, we are using the Revit data.
Yeah, we are using Revit for modeling. There are
Hmm.
yeah
And for the
different
details,
softwares are also there.
okay, okay. And then further details are put into ArcGIS Pro, or it is
For
just
spatial analysis.
only for georeferencing we are taking it in ArcGIS Pro.
No, no. Various analysis can also be done in ArcGIS Pro.
Like what means?
Like that's what the flood analysis can be done if the what is that if the building gets inside the flood or not. Those things by doing that analysis, flood analysis, we can get to know how high the water gets filled to the building, so that we'll construct the building above that level. That can also be done. Like
Okay,
noise analysis can also be done. Like floor wise noise analysis can also be done in the ArcGIS Pro.
okay.
If we know the noise levels in each floors.
Mhm. Mhm. Okay, okay.
Yes, there are many other examples.
Mhm. Okay, okay, I'll get back later on.
Yeah,
Answer,
thank
if
you.
you have done anything like that or any applications which we have done, can you present it? Any analysis?
Yes, so to understand better, right?
Yeah, yeah.
Ma'am,
So,
I don't think I have the data right now.
okay. So at least give a glimpse of what is the procedure, how the data can be taken into GS software and just an overview.
Okay, so like he just mentioned about noise mapping, right? So he told that you need what is it, data for each floor wise, right? So you may have noise devices, right? So for each of the floor again, each when you have these buildings and all, including your outside noises. Okay, so there's particular limit that we have for uh, each space. Okay, is it residential,
Okay.
commercial, any space? There's a particular noise limit. Okay, you'll have a
Okay.
threshold value, right?
So you mean to
So
say that there is a data available for the noise, and then we can just analyze using that data
it's
on the
not
particular.
available. You have to collect the data. So once you collect the data, either using
Huh?
the measuring devices, so that
Okay.
data can be added to your software,
Can be
and then
added, and then the further analysis can be done,
yes, it
right?
can be done. Yes,
So number of analysis can be done on GIS Pro software using
yes,
the input which we have put.
correct.
Okay, okay, got it. Yeah. Thank you, thank you.
Any other questions?
Sir, this 3D models
Is
can be
there a,
placed. Hello.
yeah, sorry, is there any way to get this recording?
Yeah. The link is been added on the chat. You can get it there.
Okay,
Sir,
thanks.
sir, it is possible can be placed in Google Earth, this 3D model.
Teams, once the session is completed, no, we will be uploading the recorded session, so you can review. It will be updated at least by end of the day, because we need to do some background check everything, right? So noise, everything will be there. So based on that, no, whatever is needed, we will crop to that level and update it. The link is already shared in the group where the this particular video will get uploaded.
Yeah, Pankaj. Actually, I don't know. I don't have any idea about the Google Earth engine. Uploading it to the Google Earth engine, we can
Not
actually
in,
directly
not in sir, it's Google Map or Google Earth Pro.
Google Earth Pro. That's what I don't have much idea about that. We can actually publish it in the ArcGIS online by creating the web layer from the ArcGIS Pro. We can directly publish it into the ArcGIS online application also. Where we can
So,
do some analysis also. We can explore the building layers, everything there.
okay, thank you, sir.